This is Ben. Ben knows a ton about DLCs. I think he might have actually invented them before I was born, which is quite an impressive feat.
You're welcome.
That's all I got.
I did not invent DLCs, but I worked on them for 2 years and then left to do the Bitcoin company. But DLCs is a pretty small space, so I'm still one of the experts, which is cool. So great to talk to you guys about DLCs and Lightning. And then we're not going to do an actual DLC today. I'm going to have you guys set up an Oracle, though, at the end, which should be cool. But before we even get into what a DLC is, we should probably talk about the Oracle problem and why kind of DLCs exist. It's basically like if you have a Bitcoin transaction, you want to do a smart contract, they want to do it based off anything that's outside of Bitcoin. You need to get that data from somewhere. We can't have like president election to see who won the presidential election. We need to get this data from an outside source, and it's not just embedded into the blockchain. There are some like solutions on like shitcoins where they do things like gamifying oracles, and they're not very private and they're extremely hard to scale, and there's no real good solution out there. There is no solution to the Oracle problem. There's just we're always trusting someone to get this outside data into the blockchain. It's just we need to figure out if we can't have a way to do it, let's figure out a good way to do it. So DLCs are kind of Bitcoin's way to kind of try and solve this. DLC stands for Discreet Log Contract. Discrete log is kind of a play on words. It's discrete log as in like cryptography discrete logs, but also discrete like private discrete. Programmers like to have fun. And basically it's just a contract based on a set of Oracle signatures. It's pretty basic. It was originally proposed by Taj Dryja in 2017. He's also a co-author of the Lightning Network. So shout out Taj for keeping us employed. And the first one was ever executed in 2019 between Blockstream and Crypto Garage. And this was just like, they just kind of hacked it together. Like, no libraries actually do it. They just like manually created 2 transactions and it worked. And like, we did it. And that was really it until about 2020 when around when I joined SharedBits, we started the formal specification on how to actually do DLCs. And today now there's multiple teams working on it, multiple implementations, and we'll go over that a little more later. But when we're doing a DLC or any Oracle-based contract, like we kind of want to first is like go back to like first principles, like what should this Oracle actually be doing, and like what is the ideal version of an Oracle? So they say like worst case, I don't want to have to give my driver's license to an Oracle to tell me what the Bitcoin price is. That's retarded. So and so if we go the opposite way, like what should they know about me? What should they know about anything? And ideally, and especially in the DLC's case, what we're doing is all they do is sign a message of what happened. So they'll sign the Bitcoin price is 19K. The Packers won the game. Joe Biden won the election. Whatever you want. They just sign this thing happened. And we want to prove if an Oracle behaved dishonestly. So if an Oracle said Joe Biden won, but they also said Trump won, to be able to prove like, hey, this guy's a fraudster. He's, kind of embellishing and doing both kind of things. And we should be able to punish these dishonest oracles, as well as we want to be private from these oracles. I don't want to have to give them my driver's license to get it. Ideally, they don't need to know anything about my Bitcoin transactions. They don't need to know literally anything about me. I just want to like get their signature and that's it. So before DLC is kind of the way you would do this in Bitcoin is you just have a 2 of 3 multi-sig where you'd have Alice and Bob say they're betting on the Super Bowl, and they have Oracle Olivia who's going to sign the transaction based on if Chiefs or Buccaneers won the Super Bowl. So Alice, Bob, and Olivia would create a 2 of 3 multi-sig, and then after the game, Alice and Bob would try to spend the funds from that multi-sig, and then if Alice or Bob didn't cooperate, Olivia would be there to sign the transaction for the correct person. Problem with this though is that, well, if 2 parties, if Alice and Olivia disappear or Alice and Bob disappear, funds are gone forever. But the Oracle is aware 100% of all contract details here. She knows the actual on-chain Bitcoin transactions, so you can see all of your funds and the history of them. She knows like, oh, okay, they're betting on this exact game with these odds, this time, with this amount. And the Oracle can easily collude with Alice or Bob without affecting anyone else. The only way to prove that she did collude is just like basically sharing DMs of like, hey, look, we said we're going to do this, and Alice signed it, and Olivia signed it this way. And like, it's just to be a nightmare to actually like have a real proof that they lied to you and screwed you over. And there's no way to like, if they do punish you, like that's just like, you're hoping that the people just don't like them anymore. There's no like way to get any money back or anything like that. So DLCs fix this. In the first case, if people disappear, there's a DLCs have a built-in refund mechanism. So if just nothing happens after whatever a lot of time you allow for, just your money is able to get sent back to you. And you give complete privacy from the Oracle. The Oracle doesn't have any idea what you're doing. They don't even need to know that you're using them, and they can't find out if you are using them unless you like tell them. And oracles give cryptographic proof when they're dishonest. So since they're giving a signature over an exact outcome, you can just like show this to anyone and be like, look, Olivia signed that the Buccaneers won, but they clearly didn't. And then everyone, it's just like a clear cryptographic thing that they can't undo. And another nice property is they cannot equivocate without leaking their private key. So equivocation is like when you sign for multiple outcomes. So in this case, she signed that the Buccaneers won and the Chiefs won. She would now, by doing so, leak their private key. And then so basically everything she does in the future is now like defunct because anyone could have her private key. And this allows us to do some nicer things where an oracle could set up and say like put 10 Bitcoin under that key. So then now if they equivocate and lie, well, then that 10 Bitcoin now can be stolen because their private key is open. And normally the kind of fallback is like, well, won't they just move that funds off of that key before they lie? It's like, yes, but they can put some stake behind it. If you see that money move, you're like, okay, this person's about to lie. Let's refund this contract or do anything like that. So you can protect yourself because unless I'm colluding with that oracle, I don't know which way they're going to lie. So you and your counterparty would work to fix this. But even if you do see that, you can just use multiple oracles to not have to rely on this. So you could just have like, instead of just trusting Olivia, you trust like Olivia, David, and Carol, and all these set of oracles. And as long as whatever you kind of set as your threshold, say like I want 2 of 3 oracles to be correct. If they do that, then you can just have your contract execute based off that. So if one of them goes haywire, disappears, or just is too lazy to sign it that day, then you can still execute your contract and be safe. And there's no like the setup process is the exact same. These oracles don't need to coordinate with each other, know anything about each other. All just you and your counterpart just be like, let's use these 3 oracles, and that's all you need to do. So yeah, and you get great privacy from the oracle. They don't need to know their users, and you can build it in a way where they would never know you're using them. So like at SharedBits, we built a product called the Oracle Explorer, just a website of just like where any oracle could post events and signatures. So now, like as an oracle, if you go and post an event, like here we can do an example. Here's one right here. So yeah, this is the bet I did. Ethereum, the Ethereum merge cost 15 minutes of no block production. So I did a DLC based off this, and but Chris Stewart, who's the oracle here, would have no idea. Like I'd have to go and I'm just downloading this hex, copy pasting it into my wallet, and unless you're the owner of the website and tracking IPs and doing kind of all that stuff, maybe you can know I used it, but you will never actually be able to find that correlated with my Bitcoin transaction. So like it's extremely hard there to actually correlate the user to the actual oracle use. Oops. Yeah, and they can't just go look on the blockchain and see like this transaction has my signature in it. All the like contract logic and everything like that is happening off chain. This results in a normal Bitcoin transaction. So they can't actually know you're using them by just looking at just scanning every transaction and be like, oh look, there's my signature. No, it happens all off chain. So it just looks like normal transactions. And the oracle would have no idea you're ever using them unless you told them. So how did we do this? Sounds pretty cool. So we're gonna give an example again. Alice and Bob are betting on the Super Bowl. And we're gonna have Oracle Olivia. And this time, instead of signing the transaction, she's gonna sign a message: Chiefs or Buccaneers of who wins. And instead of the 2 of 3 multi-sig, Alice and Bob created a 2 of 2 multi-sig. And spending from that multi-sig, they create a closing transaction for each possible outcome. So in this case, it'd be Chiefs or Buccaneers. And then they sign these transactions using adapter signatures. And then after that, they create a refund transaction locked to a later date in case the Oracle never signs. But I said that word adapter signature, and what the fuck is that? So an adapter signature is just a signature, but it's invalid. It can only be made valid with a secret. And you can prove this. So if you give yourself an adapter signature, you can verify that one, it'll become correct if I get that secret. And you can verify that secret is the secret you expect. So I say here scalar and a point. Think of that as well, just as like private key, public key. So you can give me a signature and a public key, and I can verify if I had the private key to this public key, I can make the signature valid. It's doable with ECDSA and Schnorr. So old version and new version of Bitcoin signatures are both doable. And to explain how that works, these is fancy cryptography math that, frankly, I don't understand, but apparently it works. So I don't know, I trust it, but yeah. So how do we do this? Finally, those closing transactions are signed with these adapter signatures. And the adapter signature is like a public key is based off the set of Oracle signatures that we could get. So that Oracle tells us, that she's going to sign Buccaneers or Chiefs. And with those 2 outcomes, she gives us like basically hashes for those. And with those hashes, we can compute a public key of how she's going to sign it. And then once she actually gives that signature, that'll basically be able to take that public key and turn it into a private key based off that signature using some more fancy math. And that from that signature, we're able to extract that secret. And with that secret, we can make one of those signatures valid to then create a valid closing transaction and broadcast it out. And then if that never happens, we just use a refund transaction. That was a little much there. Is there any questions, or am I cool to move on? So basically, a signature is an R value and an S value. And in the Oracle signature, the Oracle announcement, before you even have the event, they give you that R value pre-committed. And then once they sign it, now you have the R and the S value. And you're able to basically subtract a number from that S value and be able to get a secret from there. Because basically, since you know their public key and the R value beforehand, you have like basically the signature's public key. And once they broadcast it, the real signature, you're able to extract the private key from that S value. Not the Oracle's private key, but like an ephemeral private key that's unique to that signature. Yes. You had your hand up first. Yeah. So the Oracle private key is revealed here because if they sign for 2 different messages, then basically you extract that secret from 2 signatures, and you can use that against their public key to like kind of the algebra works out where you can steal their private keys through there. Yeah, fancy math, but yeah, that's where it lets you steal the private key. Super. What's your question? Super would like to repeat his question, so this is his question. But yeah. So we're gonna walk through that in a little more visual way of how these look. So this is your funding transaction. Someone does something like a Lightning channel, or exactly the same footprint as a dual funded Lightning channel. But these first you have Alice and Bob's inputs, so they're just taking their money that they got through like working or whatever, and they're creating a 2 of 2 multi-sig, and they get their change back. And then they create some closing transactions that spends that 2 of 2 multi-sig to the payouts that they deserve. So if they're betting all or nothing, it'd be maybe only Alice or only Bob's payout. But if they're doing something more granular, they can both get paid out a proportion of the bet size. And they create these adapter signatures that are invalid until we get that Oracle secret. So once we have that Oracle signature, we can take that plus our adapter signatures, combine them into a valid signature, and be able to spend our closing transaction. So why do you care? Building cool shit is fun. I mean, I think DLCs are pretty cool, so they're cool to work on. But besides that, it lets you do DeFi-like things on Bitcoin. Like we just gave, this is like a prop bet, just betting on things like Super Bowl or the elections. But besides that, but if you don't want to be a degen, maybe a different version of a degen, you can do like financial derivatives or pseudo stable coins. I know when I was working at SharedBits, we would get reached out to all the time by like HRF and different people because basically they want to build stable coins on top of Bitcoin using this, where instead of betting on the Super Bowl, you take a bet on the Bitcoin price, and then if holding Bitcoin but betting against Bitcoin price, you're effectively holding dollars without actually holding it. Yeah. Galoy may be doing something like this now. But yeah, so that's kind of the idea. But what about Lightning? On-chain is never going to scale. We need to use Lightning. So there are other ways to do DLCs on Lightning. They all have different trade-offs and complexities. Most of the solutions kind of require a major overhaul of Lightning. But luckily, some of these major overhauls are coming anyways, but there are other ways to do it too. So the major ways are PTLCs, which should be coming eventually. Or we rework just fundamental parts of how Lightning works, or we need some soft forks and actual base layer Bitcoin. So there's kind of two main categories of these. There's having like a single channel DLC where, say, like me and Bob have a channel, then we can do DLCs together. But unlike with Lightning, where you can route these payments across the entire network, you couldn't do that with these style DLCs. It's just only your direct channel partner. Then there are these routed DLCs where you could do a DLC with anyone on the actual Lightning network. The problem is though, say like you have one against 5 hops. Now that liquidity will need to be locked across the entire time of the bet. So there are some trade-offs there, but we'll get into that. So the first is just we're starting off in these single channel DLC styles, just adding an extra commitment output to your commitment transaction in Lightning. So in Lightning, you have this your just channel where you fund this to multi-sig. And the way that your payments work is you create a commitment transaction, and then you add outputs for every payment until they're settled. And this will just add, instead of having like HTLCs for your Lightning payments, you have a DLC commitment output. And then this is just always used for any ongoing DLCs. It's really the easiest way to do it today. The problem is though, anytime you route a payment, you need to re-update and re-sign this DLC, which can be fine if it's like, oh, I'm betting if it's Buccaneers or Chiefs, it's like 2 signatures. But if you're betting on the Bitcoin price, that could be like hundreds of thousands of signatures every time you route a payment. So it's not really scalable, but it would be the easiest way to do it today. The way that you would fix this though is using any priv out. This is a potential soft fork to Bitcoin. Basically lets you have signatures that don't commit to those inputs. So you would do it the exact same way as this commit. We've talked about this extra commitment output, but it fixes that re-signing problem where, because your signature no longer commits those inputs, you don't need to constantly re-sign, and those signatures will always stay valid. Another way that there actually is an implementation on this being worked on by Crypto Garage. It's called a sub channel. Basically, instead of having a commitment transaction, you have kind of just multiple commitment transactions where you have like a commitment transaction and then multiple commitment transactions on top of it. So you'd say like you're spending your multi-sig and then you spend that into a tree of them. And so one of them, you'll have like a Lightning commitment transaction. You'd have like a DLC's commitment transaction. You could have, maybe when people invent more stuff, you could add even more stuff on top of that. And this would fix that re-signing problem because now your Lightning channel would be on a separate transaction than your DLCs. So you wouldn't have to run into that re-signing problem. Problem is this is like one of the most base assumptions of all Lightning implementations. So it would require like major overhauls of how Lightning and the actual code works. But I think Crypto Garage built like a proof of concept in Rust. It only does DLCs, not the Lightning part, but essentially allows you to have like if I have a DLC channel with a counterparty, now we can do DLCs all day without ever broadcasting them on chain. We just, settle it into our channel, and then eventually we can close that channel. And then, if my counterparty is dishonest, you could do a force close. We just need that Oracle signature to force close it. So that was those single channel DLC ways. They're a little complicated. The routed DLCs are somewhat easier. So the first is using PTLCs, and to get started, these are like coming to Bitcoin or to Lightning no matter what. Even if DLCs didn't existed, they're like a privacy increase to Lightning. They fix some security bugs, and they have some other nicer properties about like storage requirements and stuff like that. And basically, PTLC is a point time lock, condom 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 lock, where we're revealing a secret to a point. And this lets us basically do fancy math based off these points. So like when you hash something, you lose information about what you previously had as your preimage. You can't like add 1 to 1 on one side and it'll show up like you added 1 to the hash. That's like a fundamental property of it. But with points, if I add 1 to my private key, it'll add 1 times G to my public key. So you can do more things based off that. So instead of having these adapter signatures for spending to our closing transaction, we can just have a adapter signature that closes out our Lightning payment. And email lists, and then finally the Bitcoin S repo, which is the Scala implementation of DLCs that I worked on. That's kind of the gist of how DLCs and Lightning works. If you got any questions, you can do that, and then we're going to all set up an Oracle, hopefully, and actually test some events, I guess. Oh, you want to do a bet? Okay. Hopefully my note's synced, but yeah, we can do one. So Crystal Bull is the Oracle, and then the Shared Bits wallet is like the actual DLC wallet. But yeah, we can do both. But yeah, so do you have any other questions, or we can? All right. Mm-hmm. Yeah. So basically you can have like a 2 of 3 or 3 of 5, 69 of 100, whatever you want. The basically how it would work is instead of like saying, okay, my secret is this because Olivia is going to sign it to this, you say, okay, Olivia is going to sign, it's going to look like this. Carol's going to sign, it's going to look like this. Bob's going to sign, it's like this. You just add them all together, and then that's your point. So then when they sign, you just add them up together, and then you're able to get your secret, just like the sum of their secrets. It gets a little complicated because you need a secret for Alice, Bob, Dave, Alice, Bob, Edward, and then then Bob, Carol, Edward, or whatever. Like it gets a little complicated there, but that's how you have to do it. So it does. If you did like a 60 of 100, it'd get your amount of signatures you need to do. It gets very large, but and at SharedBits we were testing with this, and like we did a bet on the Bitcoin price with a 2 of 3 oracles, and so that was like 20,000 outcomes with 3, or maybe it was like no, I think it was like 5,000 outcomes with 2 of 3 oracles, and I got to like 80,000 signatures, and which was like a gigabyte of signatures or something, and it blew up our computers, but it's more optimized now, so it works. But yeah, that's essentially what we're doing is the signature aggregation. So do it non-interactively, where it's like Alice and Bob oracles, to have them not interact. You need to do it on your self client side by like adding the resulting signatures together. But if like say like Alice and Bob are like Kraken and Coinbase and they have a business agreement, they could also just do like a musig together to result in one signature, and that would give you basically a signature that represents both of them without having to do that like fancy stuff on your end, and save you and your computation time. Yeah. So when we're doing a bet on the Bitcoin price, basically what we're doing is, okay, what's going to be the number between 0, and then we have to pick like another number. So it's like you need to account for like between 0 and I think we did like 65,000 or something. So it's like, okay, like you get a lot of outcomes there. Yeah. So basically, you always need a signature for every type of every possible outcome. So if you wanted to do like is over 20K, you could have like a oracle that's signing just the price, and you do it based off that, or you can just have an oracle say, is it over 20K, and then you only have like yes or no for your outcome. So it gets simpler. So yeah, there are ways we try to like make it better. I think we can probably maybe show that in here. But like we added things like rounding, and basically like there's a lot of like fancy algebra going on to make it better. But the major thing we did was like rounding. So instead of like having a pay, we did like, okay, a Satoshi is like kind of worthless. Let's do per 1,000 Satoshis. Like I'll get within 50 cents, and that reduced the signatures like 100-fold or something. So stuff like that, you're able to optimize a lot better. Yeah. So when we have those adapter signatures, they're all going to be specific to like the actual oracles that what the oracle signs. So if the oracle signs like the price is 19,442, if we don't have a signature for that, then it can't actually broadcast a transaction to close it. So you need to account for every single outcome. And there are like I guess you could have cases where you could say like, okay, the price of Bitcoin going to 0 is not going to happen, so we'll just not sign that. But generally, it's kind of bad practice. So you just kind of account for everything. Yeah.
I was going to mention like Cash talked about like how to essentially reduce the signature to where you sort of sign for different decimal places, different precision.
Yeah. So the way we actually do it, instead of signing like 20,000, what we do is we break 20,000 into binary digits, and then you sign like the first digit is 0, the second digit is 1, 0, 1, whatever, blah blah blah, and then you're able to like compact it down a lot, where you can have like, okay, it turns out that when the price is like I win all the money if the price is over 20K, and turns out that means that this digit needs to be 1, and everything else after that doesn't matter. So you're able to like basically just have like one signature for all those cases and save on a lot of space. So yeah, there are like, it gets really complicated. It's all in the DLC spec, but there's some fancy algebra that happens to break all that down into like simplified and compacts the space a lot. But yeah, it was a cool research project going through it. At first we thought, oh, we probably want to do like base 16 or something, like a high base, so we have like only a few outcomes. Then we would break it down to that. But it turned out binary is the best way to do it. We also looked into like, okay, what if the oracle signed binary and hex and like decimal, and turns out it was just like binary is just basically always the best case. So yeah, we do have ideas too though, where like you could do like kind of a mixture of like the binary, but as well having like these like thresholds where it's like, is like, instead of like having like a just the price, you say like is over 50K, yes or no, plus this binary, and you're able to like save a lot of space on there too. So I mean, ongoing research problem, but yeah, this is a lot of math and specking things out. Yeah, and how finding an oracle you trust is it's kind of a personal problem. It's like, who do you trust? But like Normally, I mean, like, so like this is a site we made at SharedBit, so it's just like kind of just like an aggregator of all oracles. So I mean, it's kind of filled with the bot they made, but like, it really you can just like look through their history and be like, okay, like, who won this game, or you can see like have they lied in the past. If they have, well, you probably shouldn't trust them. But otherwise, like, I mean, it's just down to like, it's really just their history. Like, there's no other really way around that unless you like know them. Like, say like if Carr was an oracle, like, well, I trust Carr to do that. I can, if he lies, can go break his kneecaps. So, but yeah, like that's kind of the gist of it, I guess. Yeah. Yeah. I mean, this isn't like a totally Bitcoin specific problem. Like shitcoin worlds have lots of oracles, and like for like there's like trillions of dollars, or not trillions, but like hundreds of billions of dollars reliant on like if Coinbase signs the right price or not. So like the shitcoins have figured it out, and their shit doesn't work. So like I feel like we'll be able to figure it out. But yeah. Yeah. So Atomic Finance, their like beta app was betting on the 2020 election, and as we know, the 2020 election was like who actually won, blah blah blah. So they signed it like, I don't know, in December, and people are like, it's not decided yet, and we're really mad. But yeah. Yeah, so the oracle will never be an output of the transaction, but this is something we thought about a lot of Shivers, is how does oracles make money? So there's like two main ways we thought of, which was one, which would just be like, instead of like just posting it to a website and seeing like, oh, their signature is this, you could like have like make a lightning payment of like 100 sats to get the signature. So then, if they have like 1,000 users, they're actually making like okay income and stuff like that. Another thing we saw is too is like, if you know like John Carvalho's podcast, what he does is like you need to like um, donate this much, and then once it reaches the threshold, then the podcast is released. Do the same thing, but with the oracle signatures, like there's a bounty for the signature basically, and once it's done, then you'd release the signature. The nice thing too is you can do with the lightning payment one, you can kind of do it cryptographically where it's untrusted, where you could encrypt the signature with the lightning payment, so they would, if they make the payment, then they're guaranteed to have the signature, and they can verify that the signature is correct for actually making the payment. So you can do some fancy stuff there, but yeah. Mm-hmm. Yeah. With the lightning payment, it's extremely private. Yeah, so like worst case is they get your IP, just host a Tor version of it, and you're good. But yeah. Yeah, that's great. And as well, you could have it where it's just like, I don't trust Stat News to make the correct call, but Stat News user 123, that's my guy, and I just always use his signatures and stuff like that too. So because like I think like with shitcoins, a lot of times they're like versions of this. It's just like these are the oracles for the contract. You use it or not. Versus like with this, it's always up to the users to pick what they want. So that helps a lot. Yeah, cheating, great revenue model as well. You get burned a little bit, but it could work. That's why I pick trusted oracles or use multiple. Yeah. Yeah, so there's basically like, this is like the entire contract is just you fund it initially, and you fund this 2 of 2 multisig, and then you spend from it. That's all there really ever is. So you're not revealing your contract or anything to anyone here. All you're just saying is money's in this multisig, and then money is suddenly not in the multisig. That's really it. But yeah, there's like stark events where that happens, but that's about it. No, so the two people in this multisig are both Alice and Bob, but so Alice has a signature from Bob that can only be made valid if she gets that secret from the Oracle, and vice versa. So like the Oracle doesn't know that this transaction is happening. All the Oracle is doing is like, here's what happens, and then Bob can go take that and create his valid transaction without Alice or the Oracle ever like interacting with him afterwards. Yeah, yes. With Taproot, it can be a one-of-one multisig, or not even a multisig kind of thing. So that it makes it a lot more private too. But yeah, not that I know of. It's been on our agenda of the spec meeting for like a year now, but we always run out of time to talk about it. Yeah, we could. I mean, you could hack together pretty easily to do it, but yeah, it's not been done yet. The code went up, maybe. I don't know. I don't like. The problem is Sherbet's Wall doesn't have Taproot support yet. We only have Taproot validation. So I refuse to work in JavaScript. Yeah, so in Bitcoin S we have Taproot like validation, which is what I worked on. But like our wallet can't like send and receive from Taproot yet. But we can validate Taproot transactions. That's probably something I should work on. But yeah. Welcome to the infinite abyss. Oh, never mind. So yeah, I guess we're gonna set up an Oracle, and then me and we're gonna do a bet, but we'll see. I need to deposit some money into here, and my wallet's not working. So that might take me to the releases, or you can go to github.com/bitcoin-s/releases, and you can download it, or maybe it's at let's do here shardbits.com. The Wi-Fi Federal Reserve, and then the password's time chain 2009 exclamation point with a capital T. It's over here if you need to look at it too. Is that on here? Oh, this is Umbral. Oh, here we go. I tweeted it out, but URL shortener. Oh, that wasn't me. Okay. Thanks.
So under Bitcoin S, on GitHub, where do we go from there?
If you go to the releases, there should be a Crystal Bowl, one of the binaries you can download. And I'm just signing up this for the first time on my computer too, so we'll get to see the full process. Thanks. Sponsored by Bounty. I know, right? Go to the releases, you can download the binary. There should be, oh shoot. There's a .deb. Is there no Windows one? Oh shoot. There's a Windows and a Mac one, I guess. Yeah, I guess, there's no Windows release? Yeah, so I guess you can download the jar. Yeah. If only. Sorry, I thought there was a Windows release. I guess there's not. That's kind of annoying. Well, I'm on Linux, so I'm gonna install it. dpkg. Yeah. Otherwise, you can download the jar and then run that with Java. But yeah. Okay. But once you have it downloaded, it should look like this. Welcome to Crystal Bull. You can click this and get laser eyes. But yeah, I mean, it's pretty simple of what an oracle does. You have a public key. This is just randomly generated, and then it has a staking address. So this is like the address that's associated with this public key. So I could send funds to here, and now if I lie, people could steal my money. But you can set a name. Ben the Carmans. Let's just do PlebLab demo. Set oracle name. And then you just create an announcement. So kind of like we were talking about earlier, there's two different types of ways to do this. There's the enum way, where you just have to like individually list out like each individual thing, or there's this numeric way where you have to like sorry.
Sorry to interrupt, but you have a dot inside.
Oh, there is. Okay, there's a .msi. Is there really? Oh, are you? It should just go into your applications list. It shows up in mine. I think does it just show up here too? Yeah, if you could just type in crystal-bowl from your terminal, it should start running too.
Everybody caught up? Who's behind? Who's trying to figure out who it is? All right, and we're gonna tell jokes and wait.
All right. Wi-Fi. You should create a new oracle. Oh, so you guys might be on the old Java version of it. So there's two versions of it. This is the one that we made in JavaScript, sadly, but there's the but yeah, so the Crystal Bull repo, if you go to Bitcoin S/Crystal Bull, that has the old Java repo. But if you go to the Bitcoin S releases, like Bitcoin S/Bitcoin S, that has the newer. Oh, this is the wrong thing. Go to the releases here. This has the newer one. I tweeted out the link to the actual release. If that should make it a little better, but all right. I love you, Super. All right, so it should look like something like this or an uglier version, but they have the same functionality. I would create a new one. It should give you 24 words. You can write them down if you want, but it's just your oracle. No, you could if you lose them, your oracle will be lost, but it's okay. There's no money on it. Yeah. Has everyone created an oracle? All right. So what are you doing for a password? Password is not SQL, so it should be safe. But yeah, once you've created an oracle, you should have either a screen that looks like that. I should download the other one since it seems like everyone's on that one. Oh yeah, these ones are. Yes, the advanced mode lets you break things. So yeah, so I guess I can, while this is downloading too, I can talk about that. So like something we talked about was like, oh, if you sign, say like for two outcomes for the same event, you would reveal your private key. So originally we made it in the software where it's illegal to do because we don't want people to reveal their private key. But then we had kept like accidentally screwing up and signing the wrong event. So we had to add a way to delete your signature and redo it. And so that's what advanced mode kind of lets you do, is stuff like that. So like, if you broadcast both signatures, you would be screwed. But if you're using advanced mode, hopefully you know what you're doing. That's what I said, but people still wanted to add it, so let's see. Can't type. How do you run this? Whatever, I'll just use this. So we're gonna have to get into that. So yeah, so we have two different types of announcements. There's enum and numeric. So enum is like what we were talking about, where it's just like Chiefs or Buccaneers, or it is sunny, rainy, or cloudy, or partly cloudy. Like you're just writing out each like individual outcomes. Versus numeric is just like you're saying it's a range of numbers. So here you just give a min and a max value of what this range could be from. So I don't know. Normally what I like to do is a coin flip. That's the easiest. So you can call it coin flip 1 and maturation time. So like this is kind of like saying like when we expect the outcome to happen. This is like kind of just ephemeral, but normally it's used to say like, if I'm saying this coin flip happens in a year from now, then when you create your DLC, you don't have your refund transaction happen tomorrow, and then you can broadcast the refund transaction before the event actually happens. So normally this maturation time is to help with different things like that. So we'll say we're gonna coin flip, and we'll do heads, tails, and something we always basically in every DLC we always try to put an other case just in case something bad happens. Say we flip the coin, it lands on its side. Well, what do we account for then? Or say you flip the coin and a nuke drops. Well, then what do we put? The coin never landed. So kind of just putting an other case. For flipping a coin, it's not as important. But like say for like a soccer game or a football game, the game gets canceled. So then, which outcome do you sign? You don't know. So, and if the oracle doesn't sign anything, then it looks bad. And then for the DLC participants, their money's locked in there now for a long time. So normally putting other case is a good idea. So that just creates an announcement, and I think you just click here. And it broadcasts it to the Oracle Explorer. So now it should show up. You have to like broadcast. There's a button to broadcast it, I think. And then it should show up there. So mine says PlebLab demo coin flip 1. And then it has this like random letters and strings. Looks confusing. This is like our announcement. So this is what a user would put into their wallet to actually do a DLC. You're gonna click the JSON button to like see what's actually comprised of this announcement. So it has like our public key and a signature. So the signature is just kind of signing like with your oracle's key, like this is my announcement. So people can't come and say like can't just like create a fake announcement for someone else, so you can prove that this is your announcement. And then we have the nonce, which this will let us actually build a DLC, and then the name of it, coin flip, and then outcomes, head, tails, or other time. Yeah, that's like the basics of a announcement. Yeah, so once you sign it, you can let's do like an online coin flipper.
Everybody caught up at this point? Anyone's struggling?
All right, we're gonna flip a coin. It's heads. So we would just like pick heads was the outcome, sign it, and then broadcast outcome. And if we go back. Yeah, so now our signature is here. So if someone had a DLC on this, they could execute their DLC. You can see it has like, again, our oracle's public key. And now it has the signature that actually signs that outcome heads. And yeah, it says we did heads. That's like the basics of an oracle. It's like, you can see, extremely simple. So this is something like that makes me excited about DLCs, is like how simple it is for an oracle to exist. Like you don't need to be like running hardcore infrastructure or anything like that. It's like you're sending out like a kilobyte of data, if even. So like it could be Coinbase or Kraken, or it could be some random guy with a cell phone in Nigeria, and they can do the exact same job. Yeah, so if you wanted to like say like do it for like every single NFL game, you probably need to actually write some software. But yeah, that is possible to do. So like at SuredBits, yeah. So it in the background of this, it's running like an RPC server, so you could like just make actual like commands to it. But at SuredBits, we have a bot that I guess every day it signs the Bitcoin price. So like that's something we built. So I don't know, like in Atomic Finance, in their app actually uses our bot for the price. So like it is something that you could easily build. Yeah.
Do you have like a boilerplate contract to go with this, or is there anybody that wants to make a bet against any one of these oracle signatures? They have to create their own.
Yeah, so we have on here is like, so these are like all the announcements. We actually have like contract templates that we call them, are like so this is different ways you can post like, oh, a bet I'm doing. So this was Iowa versus Illinois, and probably a football game, and I guess it hasn't happened yet, but yeah. So you can see the announcement here is like Iowa versus Illinois, but you can also view the contract, and you can see, okay, you can have what that is, 100,000 sats on Iowa or 0 sats on Illinois, and then get your money back on other. So yeah, this is like a template you could enter into your wallet and be like, hey, this is a popular contract everyone's doing. I want to bet on it too. The SuredBits wallet. Yeah. That's on same download page. It's in Bitcoin S /Bitcoin S in the releases. It's also on like Umbrel, I think. Might be on the other ones, but yeah. The one of the harder problems that with DLCs, however, though, is the matchmaking problem. So I could be like, I want to bet $1 million on the Broncos winning the football game, but finding that person that will stick the other side of the bet is a harder problem. There is no like central order book of like where to make these bets. So right now people just use like Telegram, or just find a friend. But yeah, if you download it, you just still need to find like someone to bet against. Up here at the top, there's like so there's like, they organize it by enum and numeric. Yeah. Yeah, a lot of these are just like, the idea was it to like go popular bets. if our website goes down, DLCs still work. This is just kind of just an aggregator for events. It's like the weird thing of it as like, as like mempool space. With mempool space, I can go and find any Bitcoin transaction that's happened and any block and kind of see what happens. But mempool space is not Bitcoin. It's just a way to view Bitcoin. This is kind of similar idea. Shared bits is not DLCs. It's just a way to view DLC contracts and oracles.
So is this I can't read the address part. Is this sharedbits.com?
Oracle.sharedbits.com. Sorry.
Okay. I'm on that site and I don't have I don't have that top bar.
You don't? What browser are you on?
Oh, so yeah, apparently if you're on like mobile or something, it just disappears.
Oh. Yeah, we're not much of web devs at Shared Bits.
Oh yeah, there's no menu bar on mobile. Show all those stuff.
All right, but yeah, that's the basics of making Oracle. But yeah, doing a bet, I can just kind of show you this is the Shared Bits wallet. This is my bet I did against Chris on will the Ethereum merge cost 15 minutes of no block production. So yeah, I was ill-advised, but I trust Chris. But yeah, we had the yes outcome, the no outcome, or other. That's kind of small. Can I zoom it in? No. And there's my payout address, and there's different data here about like the ID and contract info, stuff like that. But yeah.
Just to be clear, if I wanted to create my own contract, so what I would do is I would essentially make sure that the output that pays me, if I'm correct, would be the signature from the Oracle for the outcome that I'm betting on, plus my public key, or what would be that additional?
Yeah, so and the way we construct these is called a contract info. So basically you kind of just say like, basically in the beginning of your DLC setup, you say, this is my payout address. And then your counterparty says too. And then you have a contract info just specifying payouts. So you'll say like, on the case, yes, Ethereum has 15 minutes of blocks not being produced. Then you just say like, I get this much money. And then, they just subtract. So, okay, you say I get 100,000 sats and the total bet is 1.5 million sats, then you subtract that for the other for the no case or the other case.
But for the actual payout, what is the address? So the address is the actual public key. So that's providing public key.
No. So the address is just a generic address you give. It's just like, here's my address, and then the only fancy part with that Oracle signature is the actual signatures you use for spending your multi-sig. So your multi-sig is so you basically like, you're just saying like, here's my address, and then you say, okay, let's fund this multi-sig, and the spending transactions are going to be where we use that Oracle signature to like give a invalid signature that only becomes valid once the Oracle gives us our signature.
Okay, so are you tweaking the signature?
Yeah, that's essentially tweaking it. It's on the not Bitcoin S / Crystal Bull, but where to go? Bitcoin S / Bitcoin S. In the releases, there's like if you go to the latest release in the actual like downloads for it, there's one of them. It's called Crystal Bull right here. Well, no, so like in the latest release, if you go to like the downloads for it, the assets. Yeah. I think that one doesn't have that's the one I was using with the prettier UI. Yeah, On the 1.9.3, there's the Mac release, but I don't know why none of them have the Windows release. This one doesn't either. I mean, I can read through that. Oh, they have Windows commented out. Yeah, I don't know why.
Oh, I see it. Crystal Bowl 195.
Yeah.
So can we like make an actual bet right now?
Yeah, my wallet doesn't have any money in it. My mobile wallet's not working, but we can try to make a bet. Let's see. Can we SSH into my thing at home?
So SureFit's wallet is the best thing to use.
It's the only thing to use, but yeah. I have word that pizza is on the way. Pizza is on the way. I guess we can walk through as well, like creating a DLC like offer. So we can take this coin flip. How do we copy paste it? There, we'll go to here. Awesome. So when we want to build like the actual DLC to like give to a counterparty, we can you would take that announcement that the Oracle gave us and like paste it into your DLC wallet. And this lets us create an offer. So basically, like a DLC offer is just saying like, I would like to bet against you. This is what the bet would be, and then you can choose to accept it or not. Similar to like a lighting invoice is kind of the easiest way to think about it. So here we have it automatically filled in the coin flip event ID for us. It has a maturity date saying it's going to happen in 2 days, and the refund date. So I think we just put it like a week after. So this is like, you know, if the coin flip never happens, then you get your money back. And then we can kind of bet how much money we want to do here. So for collateral in total, we'll say like, you know, it's going to be 100,000 sats. And I want to bet, yeah, it filled in for us, you know, half mine, half counterparties. And then we need to fill in the actual payout for each of these outcomes. So for heads, we'll say we'll get 100,000, and tails we would get 0, and then for other we'd get 50,000. So in heads case, we win all the money. Tails, we get none of the money, and other we get, you know, our money back. And then this fills in a fee rate for us, and then we could send this to someone. I don't have any money in my wallet right now, so it wouldn't work. Does this thing work? Ooh, okay. No, go ahead. And you could do that, but like, what if the game never happens? I guess, yeah, you could do something like that. Or if the Oracle never signs though, then the other person wins, which kind of sucks. Then they could like DDoS the Oracle or something. But I mean, it's a way you could do it, but you can't get as granular. If you wanted to do like what's the Bitcoin price, you can't do is $900 and $400 or whatever, or nothing. Yeah, you could do like is over, but that doesn't work for like as granular stuff. You want to do like a payout curve and stuff, but yeah. I mean, at the end of the day, it's like your oracle is what they say. What is what happens. So like, if say like, me and Carr had a bet, and the oracle lied, and Carr won the bet when he shouldn't have. Like, basically, you're just kind of screwed. And it's like you should use more different oracles then. Yeah, I mean, so you could have is like the payouts go somewhere to that's like a multi-sig that, so it's like, oh, if say like the payout goes to this address, and then this address has a multi-sig, so if it was a lie, then like our lawyer can sign it and be like, actually no, that's wrong, and it goes to the correct person. If you're doing that though, it kind of defeats the purposes of DLCs. It's like, yeah, just have that guy be the oracles. At the end of the day, like, the Bitcoin's going somewhere, so you need the person that you're trusting the most to like say like where the money goes should just be your oracle. So if you say like this remediation process to decide where the money goes, well then they should just give the signature of like who won the Super Bowl, because if you're going to trust them to pick where the money goes, then just use them originally instead of having them as a fallback process. I mean, so you don't need it to be like one person for all DLCs. Like, oh, yeah, I mean, it depends. Like, it could work out like that, but it could just work out like you trust different people than I. So, I use the NFL Oracle and you use the Sports Center Oracle, and like I like Taco Bell, you like Taco John's. It's like, there's room for competition, and yeah, exactly. And like the Oracle is like, I don't need to use just one. I could use the NFL and the Sports Center Oracle, and I trust them. They both need to cooperate, otherwise nothing happens. So you could do stuff like that too, where you're not always just trusting one person, you're trusting this aggregate of people, and hopefully they come to the correct conclusion. Yeah. You can automate it, but yeah. Yeah. I mean, like my computer died, but the shared bits oracle, like that's just happening every day, unless like Amazon turns it off. But that's just gonna happen, and like it's just kind of unbiased now, where it's the program executes and the price of Bitcoin assigned. It's not like we have people like typing it in and reviewing everything. It's just like code executes and it happens. Yeah. Yeah, you're welcome. My computer died at the end, but